Thanks, Rena. Thanks, Rena. Hi. Okay, we can start. So we're going to start a new topic today. We're going to start vectors and scalars. And most of you know what these are. I'm going to set them up very systematically. Toward the end of the discussion, not today, but toward the end of the week, I'm going to tell you what a vector really is, or what a scalar really is, because it's not what you think they are. Okay, but we'll start off with a useful way of looking at things. Okay, so we're going to say all quantities in nature can be classified as either a scalar or a vector. Okay, and let me just stop right there. I've already told you a lie. It turns out there are many other things in the universe other than vectors or scalars. These are just two of the more common things. It turns out there's something referred to as nth-rank tensors, and there's a whole bunch of things. But this isn't that bad of a lie. This is useful. Okay. Now most of you know what these are, but let's assume you don't. So what's a scalar? Yeah. A scalar is going to be something that only has a magnitude. It doesn't point in any direction. So a scalar is a quantity with magnitude only. It has no direction. Okay, so give me some examples of a scalar. Put units on it, and I may agree with that. Okay, so if you just talk about a regular like distance between 2 points, you have to be careful with that one. So it depends, because that can actually have direction with it. Okay, that'd be another, that would work depending on what you mean by 2 inches. So in other words, if I want to measure the length of something, so let's say the length of this is, let's say 4 inches. That would be a scalar, okay? So I could measure, say the length of something, that would be a scalar. There's more easy ones. That's going to have a direction with it. So we're going to, and again, we can make that into a scalar if we do something with it. Okay, so hold off on that thought. Time would be one. Okay, so time. So some examples of this are time. Right, when you say time, what is the time right now? The time right now is, 10:23. We don't say it's 10:23 going north or 10:23 going upward. To put a direction with time makes no sense. Okay, it's just time. Another one would be like, yes. Hold off on that one. Okay, because it turns out that's actually going to be a force, and that's going to be a vector. But you can actually do the weight in such a way that it isn't. So that one gets tricky. Hold off on that. Mass would be one. Okay, so another example would be mass. Okay, so something, let's say, weighs 2 kilograms, right? It doesn't weigh 2 kilograms going east, or 2 kilograms at a 45-degree angle going northwest. That would make no sense. Joule, okay, when we get to something like joules, so joules are going to be connected with what's called work or energy. And so when we get to energy, energy will be an example of a scalar. Temperature would be another example of a scalar. Okay. Temperature is kind of an we're not going to do anything with temperature in this course, but just so you know, I hope you go on to take up upper level physics courses. You'll eventually find out what temperature really is. And it's bizarre. When you find out what temperature really is, it's one of those things that's kind of like Earth changing. It's just not thermal motion, it's something weird related to entropy, but don't worry about that. Yes? Okay, so height would be a perfectly good one, right? You don't talk about height this way or this way, you're talking just about like what you measure on a tape measure like this. So, well, do it that way, then say it's a, why is this height and length so much dimension? So if you just talk about the length of this, you'd be okay for this. So often dimensions over a room, like dimensions over a room, dimensions. Okay, these are going to be nice, and we're going to love these. You can do a lot of easy things with these. Okay, now let's talk about something called vectors. Yes. So a vector, what do you think that's going to be then? Yes. Exactly, that's what one is. So this is going to be a quantity that has magnitude and okay, give me some examples of this. Okay, velocity is going to be one of the classic ones. So velocity. So if we see a car going down the road, what do we say? We say going, 55 miles an hour north. We give it a magnitude and we give it a direction. Right now. Okay, displacement is going to be, if you take like an initial distance and a final distance, that's going to be one as well. So you can say displacement. Maybe. Okay, we're going to find out a force. So we don't know what a force is yet. A force is going to be basically something that's going to cause an acceleration, but it's going to be like a push or a pull. So if you push something in a direction. You give a certain magnitude of the push, but then you push in a direction. Acceleration will be another thing. Okay, these are all examples of vectors. And again, so this is going to be our initial. This definition is going to work fine. Again, probably on Friday, I'm going to give you kind of the adult definition of one. It's going to be weird, but I want you to at least see it. I'm not going to do anything with it, but I do want you to see the weird definition. Okay? So these are some examples, and what we're going to do is basically we're going to beat on these for the rest of the semester. Okay, there's a whole lot you can do with these. Yes? Yes, that'll be another one too, and that'll come third test. So there's going to be something called linear momentum. That'll be another one too. And then we're going to get something called angular momentum as well. Angular momentum is going to be pathological, just so you know. Okay? So there's a whole bunch of examples, and what I want to do today and tomorrow and on Wednesday is show you how vectors work. And so the lab you're going to do this week is going to use vectors. It's a very nice, straightforward lab. Probably the most standard lab in the entire universe. Okay, so let's ask, how do you write a vector or represent one? Okay, the way you're going to represent a vector is you're going to use an arrow. Okay, so you use an arrow. Okay, the arrow is going to have a direction with it, and that'll be the direction of the vector. And the length of the vector is going to be its magnitude. So the length of the vector is the magnitude of the vector. And the direction it points is the direction of the vector. So let's actually draw one. So let's say we have something like this. So that would be a vector. So this is the way we're going to actually write a vector is, if this is the vector v, what you do, you put a half arrow vector symbol over it. So this right here, this is a half arrow. And you put that symbol over anything that's a vector. So this v with a half arrow on it is this object here. Okay? So in books, in many books, vectors are denoted by bold print. So if you looked at this in a textbook you may not see this at all. In a textbook, what you might see, so in a textbook, you might see something like, this. You might see something really, really bold. So this would be a bold V. So in a textbook, you might see this. Obviously, that's too hard to draw on the board. So the convention is you always use a half arrow. Okay? Now the length of the vector, this right here, this is the length of the vector. So this right here is the length of the vector. And you call the length of the vector the magnitude. And the way you denote that is you take the vector v, like that, and you put absolute symbols around it. So you go like that. So this right here, this means magnitude. Okay? So this right here, the length of this guy, that would be something like this. The length of this guy here, that would be v. The fact that it's a vector means that it has some angle here like this. That's the direction part. Let's stop at that point. Does that make sense? One other thing you're going to see in textbooks. Sometimes in textbooks, when you have the magnitude of a vector, you'll just write the v without the vector symbol and not make it bold. So in textbooks, so sometimes in textbooks, a magnitude is, I'm going off the board. I'm not. A magnitude is written as just v. This is not bold. This is not bold. And there's no half arrow. It can sometimes be very confusing, especially when you're just learning how to do it. Okay? Now the question is, what can you do with vectors? And this is where everything starts getting useful. It turns out that if you have one vector, and if you have another vector, you can add vectors together. And vectors add in a very odd way. Okay, so if you have two or more vectors, those vectors can be added together. The way the vectors add in a tip-to-tail fashion. Vectors add in a tip-to-tail fashion. So let me explain what this means here. So let's say here's a vector here like this. This right here is called the tip. And this end part here, this is called the tail. So let's see how this works. So Valentine's Day is coming up, and let's say you want to get your chocolate for your significant other, but you can't find chocolate. So instead, you decide to bring them vectors. And so one vector looks like this. This is vector A. Another vector looks like this. This is vector B. Okay. Good substitute for chocolate. Question is, how do these vectors add? How do A and B add together? So what we want to ask is, what is A plus B? Okay, and they actually do, they add together very nicely. This is what you do. You start with one of the vectors. It doesn't matter if you start with this vector or if you start with this vector. The order of the vector does not matter. I'm going to start with this one just because I have it listed first. So you start with this vector, you draw it. You keep everything about that vector the same. So if this has a certain length, you draw it with that certain length. If this has a certain angle here, you draw that exact same vector with that same angle. You don't change any of that. Then what you do, I'm going to take the tail of this vector, here's the tail of B, and you add it to the tip of A. So here's the tip here of A. And I'm going to add the tail of B here. So here's the tail of B. So you take the tip of B and you add it to A here like this. And that's what your new vector would look like. A vector plus a vector is another vector. The question is, what's the direction of that final vector? So vectors, so A and B add together to make a new vector. C. So in other words, we're saying that C is A plus B. The question is, how do we draw C? Okay, C goes from the tail of A, tail of the first vector, okay, to the tip of the last vector. Okay. So how would I draw C here? Like this or like this? Yeah, you start here, start at the tail of A, the first vector, and you go to the tip of the last. It's like this. So this right here is C. Okay? Let's try another one. Oh, let's just say one other thing. Suppose I started with B here. What would be B plus A? It's the same thing. So if instead if I started with vector B, here's vector B. Okay, how do I then add a vector to that? Okay, you take the tail of A and add it to the tip of B. And then this is your vector then C. You get the same thing. Let's try another one. Let's say I have a vector like this. This is A. This is B. This is C. And this is D. I want you to draw vector E, which is going to be A plus B plus C plus D. So you have 4 vectors. You're going to add them together to make a new vector E. How will that work? Look. Yes. Prove it. Which vector do we start with? You have to start with A. You can start with anyone, but you said A first, so we're going to go with A. So the first thing you do is you start with A, so you come over to some nice little spot. You draw A exactly like what you have here. Now, which of the vectors B, C, or D should we add? Well, I mean, but now we've drawn A, now we have to count B, C, and D. So which one do we use next?
B.
I can't wait to find out. Okay, we'll look at that. Okay, the answer is going to be yes or no, depending on how you look at it. Okay, it's going to be weird. Okay, so should I draw the vector B next, C next, or D next? It doesn't matter, so I'm going to go with everyone here first.
B.
I think I heard B next. I don't know. We did or not. B? Okay. So let's draw B. So how to draw B? I take the tail here, and I add it to the tip here. And again, I have to keep the same length and don't change the angle at all. Keep going. Yeah. Now I want to add the vector C, so what do? I take the tail of C, and I add it to the tip of B. Okay, now what? Yeah, so now I'm going to take this guy, add it to the tail here, you get this. Now where's my vector E go? You start at the tail of A, and then you go to the tip here. So that's my result E. And that looks like a pentagon. But somebody else could say, well, kind of squishy pentagon, okay? It's a 5 side, which would be a pentagon. Okay, but suppose somebody says, no, I don't think it's a pentagon, I think it's a different shape. And that exactly, I don't have to draw it in this order here. Let's draw it in another fashion to get something weird. Okay, so let's start off with B. Now let's add A to that. So how A would be this way. Make this a little bit more like that. Okay. Okay. Now what? Yeah, let's add D. Okay. My vector D. Notice these are crossing, it doesn't matter. Okay. Now what? Vector C. Okay. And if I draw on the same scale here, let me just change this so I get the same scale. Like that. Okay. Where's my vector E go then? Yeah, it goes like this. So you can have, so if you're working on these problems, and let's say you do it in one order, and your friends do something else, you're going to get the same answer in the end. Your pictures are going to look different, but it doesn't matter. Okay? Let's try something else. Any questions with that? Let's say we had this. Let's say I have the vector here A, the vector here B, the vector here C like this. And I want you to draw a new vector D, which is going to be 2A minus B plus 3C. So what on earth does that mess look like? Yeah, so what do you think 2A means? It's 2a is really the vector a plus the vector a. That's why you get 2a. So this guy here is a plus a. What do you think the vector 3c is? Yeah, this guy here is c plus c plus c. Okay, now that leaves this weird guy. What do you think it means to be minus a vector? Yeah, this is going to be the opposite direction of b. So this minus b is really plus a minus b. You flip the direction. So let's actually go through and draw this. And let's see, I think it'll be okay over here. Okay, so how does 2a look? Again, it doesn't matter which I start with. I can start with this term or this term or this term. It doesn't matter. I'm usually just a left to right kind of guy, so I start left to right. So how does my friend 2a look? Yes, I'm going to have a. I have another a. So this whole combination here, this is my 2a. Okay, now how does minus b look? Yeah, b would be this. Right? That would be plus b. But we don't have that. We have minus b. So what we have is this. So we're just adding a negative b. Okay, now what? Yeah, we're going to take c plus c plus c. Where's the result? Where's our vector d? Yeah, it goes from here to there. That's the vector d. If I'd gone the other way, if I'd drawn d like this, what vector would that be? That would be negative d, exactly. So if you flip the direction here, it's a big deal because you're saying the vector is going in the opposite direction. Okay. Does that make sense? So there's one problem where on the homework that's due on Friday, I want you to actually draw this out. How would you draw this on graph paper? So you're going to do this in lab as well. So you're going to use graph paper to draw this. So how do you do this on graph paper? You come up with some sort of scale. So maybe you're going to say 1 centimeter is 10, or you're going to come up with some scale. You're going to measure things out precisely. How are you going to get the angle? A protractor, okay? So what you're going to do in lab, you're going to have some vector here. You're actually going to you're going to put down a ruler. Well, here's your paper. You're going to actually use real, honest to God, grid paper. You're going to put your little protractor here. You're going to measure off some angle. And then you're going to measure something, a certain length here like this. You're going to have some scale, and that'll be the first vector. How you add the second vector to that? Okay, you're going to imagine a tiny little xy axis up here, like that. You're going to measure the angle up from this imaginary xy axis here. Maybe it's this guy here. Then you're going to have some little vector here. You're going to use ruler here and get that guy. And then your actual vector here will then be that guy then there. So you're actually going to do this in a lab. Not hard, but it is kind of a pain when you first do it. Does that make sense? But now we can do something else. So often, when we specify a vector, the vector's magnitude and direction are given. So in other words, as an example, I might say this. Okay, so let's say you're getting your Wegmans getting a vector for your date on Friday Valentine's Day, and this is a vector you buy. What vector did you buy? What would it look like? Let's say you're going to draw this vector. How would it look? What? No. But it could be an arrow to pierce the heart. Okay, but how would it look? Show them this information here. Yeah, so here's an XY axis here. Okay. How do we specify all angles? This is a high school question. From which axis? Going which direction? You go from the x-axis and you go this way or this way? Yeah, you go this way. So you're going to come over 150 degrees this way. Okay. And then what would you draw? Something 30 units long. So this right here, this would be 30 units long. And that would be your vector A. Does that make sense? So one way you specify a vector is you give the magnitude and you give the angle. That's one way to do it. It turns out there's another way, and it's called components, and I want to talk about what it means to be a component. So another way to specify a vector is to give its components okay? And what I want to do now is talk about how you would actually, what a component is and how you specify them. And how am I doing with time? Doing fine. So let's ask, what are components? Okay, I'm going to kind of set this up in a general way and then go to something more specific. So all vectors can be viewed as being made up of other vectors called components. Let's say called component vectors. The component vectors add together to make up the actual vector. This is going to be more to our definition, but right now we're going to start with this one. Then we're going to see why we have to tinker with that definition. So let's take an example. Suppose A1 and A2 are the components of vector A. Okay? So we're going to say A1 and A2 are the components of A. What does that mean? This means that A1 plus A2 equals vector A. So we would say that these two are the components for vector A. Now, how would you draw these? And here's where the problem comes in. How do we do this? Okay, So we talked to a friend. So this is friend 1. So friend 1 says it's really easy. Our friend 1 says this is vector A1. And this is vector A2, like this. So I can think of vector A as being this component and this component. Right? So what would my vector look like? Add those for me. You take this fellow. You add this fellow. And that's my vector A. But I have another friend, friend 2. But friend 2 says, my friend 2 says, well, you know, I'm glad you have one, but your friend 1 told you something really stupid. These are not the components. What the components really are the following. Here's your vector A, but really what the components are is that this is vector A1. That's your first component. And your second component is this right here. My second friend says, right, because this vector plus this vector equals that vector. So this friend says, these are the actual components to this vector. But I have a third friend. My third friend says, well, no offense against friend 2 and friend 1, but they're not the components of the vector. The real components of the vector are the following. My friend 3 says, if this is vector A, really what it is, this one you can't draw, vector A1 comes out of the board like this. And vector A2 goes into the board like this. So this vector plus this vector equals that one here. So this friend says the components are out of the board. Yeah, so in other words, there'd be a vector like this, and then a vector like this. Okay? So this would be like A1, this would be A2, so I'd add A1 like this, A2 like this, they make that vector. And I can keep on going on with friend after friend after friend, and every friend will tell me how to do components differently. Okay, then that's not useful. You just can't have that. When you do science, you basically want to have everyone use the same definition. So we need another restriction on components. So we're going to put a restriction on components. We're going to say components must be perpendicular to one another to remove some ambiguity. Say, we need everyone's components. We need everyone to agree on what the components of A are. Therefore, we insist that the components of A let's say of a vector must be perpendicular to one another. And that's going to help, but it's not perfect. So let's see what this means. So I go to my friend 1 and I say, friend 1, I want my components to be perpendicular to each other. My friend 1 says, oh, easy, not a problem. My friend says, oh, this is your first component. That's A1. And your second component, A2, must be perpendicular to A1 by definition. So this right here is A2. A1 here, A1, and A2 are perpendicular. I'm just going to use the symbol here to each other. Hey, but what's friend 2 going to do? Yeah, friend 2 is going to say, well, no offense, I'm glad friend 1 gave you 2 perpendicular components. That's great. I mean, they need to be perpendicular, but it's not these. What they really are. Well, friend 2 says is that really your vectors are this. This really right here. This is your A1. And then perpendicular to it is this guy here, A2. These are perpendicular to each other, so they're your real components. What does friend 3 do? Yes. How does friend 3 go? Yeah, they're going to come out of the board. So friend 3 is going to say, oh, no, it's really this is vector A1, and then this is vector A2. Okay, again, we have ambiguity here. So we need one more thing to basically remove all the ambiguity so that we all agree on the components. So the way we remove the final ambiguity is we're going to say that the components are going to be taken relative to the x and y axis. So the components still vary, still differ from one friend to the next. Therefore, to remove this final ambiguity so that everyone has those exact same vectors, exact same components. So to remove any ambiguity, A, M, B, I, Q, Q, T. Okay, remove any ambiguity. Okay, we take the components. To be along the x, y, and z axis. Okay, we're not going to do z for a little while yet. We're only going to have x and y axis here. So let's see what this means here. So that means if here's my vector here, A, we define the components to be perpendicular to one another, but taken along the x and y axis. So this right here, I drop a little perpendicular here. This right here, this would be my AX right here, okay? And this would be my AY right here like this, okay? They're going to be the components of vector A. Now somebody else could say, no, no, no. Really, this and this are the components. Why does it not matter? Well, this would be nothing but, what would be this vector? That'd be my AY here. What's this vector? That's AX. Okay, so you get the same answer no matter what. So that's the final ambiguity. So our components, by definition, must be perpendicular to one another. And we take them along the x and y axis. And that guarantees that everyone has the same has the same components. Does that make sense? Okay? Now, the way we're going to do it, okay, I can set up a little bit more. So this means we can write any vector as, ax plus ay. Let's see what this means. So, if we have C equals A plus B, we can also write each of these vectors in terms of their components. Okay, so how can I write the vector C? Cx vector plus Cy vector. All right, this is going to be my C vector. Hey, how can I write the vector A? Yeah, this has to be Ax plus Ay. This is my vector A. And then likewise with B. Yeah, Bx, By. Now these are vectors, I can put them in any order. So I can put all the x's together and all the y's together. So I can just as well write this as Ax plus Bx plus Ay plus By equals this. What does this mean then? This points along the x-axis. What else points along the x-axis? This vector and then this vector. So what does it mean about this vector here? This vector must be compared to the left side, to the right side. Yeah, this has to be this guy here because they point in the same direction. And likewise, this guy here has to be what? This over here. Okay, this will make more sense when you actually do an example with it, which we will do tomorrow. We'll do a whole bunch of examples. Have a good day.